Now this one is just a matter of keeping track of all your trains. We got three identical train cars coupled together. So I'm going to draw three boxes. 1, 2, 3. These are the three identical trains. And they're rolling east at 2.1 meters per second. Got it? And we have a fourth car. Now it doesn't say it, but it has to be. They didn't give it to you. We're going to assume it's the same mass, and it's moving at 4.1 meters per second. Got it? And then when he hits, he's going to stick together, they'll couple. We're assuming no friction. And then eventually, the four are going to collide with the fifth, and he's moving at 0 meters per second. So the question is, how fast are they moving at the end of the ball game? So remember, the total momentum before and the total momentum afterward. So this will be, I'll call M1 V1, and we'll call this block 1, 2, 3, 4, and 5. So I'd say M234 times V234, add those, right? Plus, that's a 5, M5 and V5 is going to be equal to the total mass and your velocity final, if you will, okay? So you're just going to plug these in, and you say, wait a second, I don't know the masses. So guess what? Make up a number. They're all identical. So when I did the problem, I just assumed that they all weighed 1 kilogram. I know trains weigh 1,000 kilograms, but the math will work the same. So I said 1 times 4.1 plus 3, right, times 2.1 plus 1 times 0, because he's at rest, is equal to, there's 5 cars, 5 times V final. So you do the math. I mean, it's just 1 times 4.1 plus 3 times 2.1, and you divide both sides by 5, and I get the final to be 2.1 meters per second. There you go. So yeah, that makes sense. If you think about it, this is moving at 4, it hits this, and they're going to be moving at a smaller thing, but then they hit this guy, and that slows them down even farther. There you go. Solved.